Hello everyone, my name is Ivan. I'm the head of BD at Biconomy, and today I'll be talking about this super complex topic that I'm going to take about like 10 minutes, 7 minutes to explain, and then I'll show you a couple of demos to paint the whole picture so it's not just me up here yapping about technical details. So this is the title. Enabling contractless cross-chain composability on the dapp layer using modular execution environment. Now this is a mouthful, and my colleague came up with it, and I'm gonna distill this in a high-level overview, and we're not gonna spend like 12 hours talking about smart contracts and things like that. So it's gonna be super simple, easy to digest. So what is modular execution environment? It's basically a P2P network of nodes that processes user ops and intents across multiple networks. That's essentially it. It receives a user op, you tell it, execute this on Optimism, it's going to do it. Execute that on Base, it's going to do it. It's a very, very straightforward approach. ME does this by utilizing a data object that we call the super transaction. Now, what is the super transaction? It's essentially a Merkle tree where the leaves are user ops and intents. And the user signs this Merkle root hash, sends it off to the modular execution environment, and then the environment can execute these transactions across different chains. So what does that mean? In a normal transaction, let's say you want to bridge from Polygon, Optimism, Base, and then on the destination chain, you want to maybe swap, or maybe you want to supply to some Aave pool or whatever. You have to sign multiple times. You have to change network multiple times, multiple signatures, multiple gas tokens, multiple networks, just a bunch of hassle. So the super transaction, what we do is we bundle all of those things together. You sign only once, and then you give it off to the modular execution environment to make sure that everything is coordinated, that everything is executed. Basically saying, swap this, then bridge this. When it arrives on the destination chain, supply to, I don't know, Aave v3. And you sign once, it just works. So the super transaction is here. It's basically a data structure that can contain transaction context across multiple chains. So you're not doing things manually, you're not doing things, by hand. You can, with a super transaction, you can pay for example, you can pay for gas in USDC on Optimism, execute the transaction on Polygon, then switch, then bridge to Arbitrum, then you can do like an N number of transactions with a single signature. But there's an implicit problem when you're executing things across multiple chains. For example, let's say you bridge. There might be like a hidden solver fee. There might be, when you swap, there might be some slippage. So all of these things are really difficult to know in advance. So there's this implicit issue of composability that comes when you're executing transactions across multiple chains with the same context. There is this problem of just the lack of deterministic data that you're going to use to construct the call data. So for example, if there's slippage, if there are additional gas fees, let's say there's like a gas spike on the destination chain, you cannot predict that. So your transaction is most likely going to revert. However, we have this cross-chain composability, which allows us to dynamically inject parameters as your transactions are being executed. So what it's doing, it's saying, take my ETH from Base. When you bridge it, whatever the output is, swap it for USDC. Whatever the output of that is, supply it to Aave. So basically, all of a sudden, you can get this entire flow working because it's dynamically injected. And yeah, we are at the moment using Polymer for this. We are not fully integrated, but we will be using Polymer. There are a couple of other options that we are looking into, but so far, Polymer has been proven to be the most gas efficient and fastest. So yeah, we can basically control for slippage or runtime issues in real time. Yeah, that's the cross-chain composability part. Now, all of this is super cool, and like I can get into like the contracts, how exactly it works, but I'm not gonna waste time because we have to do the demos. So we're doing this at the dapp layer. The whole idea is to move this whole cross-chain complex flow from the dapp layer to the infra level. So doesn't really make much sense for the dapp to handle all of this. we have to make sure that like the developers and the dapps are like giving the instructions to the infra, which is then going to handle this complex cross-chain execution. Now, this is something that I put in, that zaps are great, but they require a lot of smart contract tinkering, and this makes it actually, there's a lot of friction when you're dealing with this. And also, they cannot really use this dynamic parameter injection like we can do with super transactions, which can preserve context across multiple chains. So the same thing that zaps are doing, we can achieve with Abstract.js, which is our framework for this entire flow. But it can be done in a much, much simpler way. And this brings me to my last point, which is basically contractless. So you don't have to write contracts that manage this cross-chain logic. Devs basically write instructions, and then we handle the rest. And it looks like this. This is like bridge from bridge USDC from OP to Arbitrum, and then basically when it arrives, then swap it, and then you can like create all of these cross-chain flows just using this. You don't have to manage smart contracts manually. And now it's demo time. And I'm just going to show you, so I'm going to show you two demos. One of them is what we call chain abstracted Aave. So there we go. So here I have some funds scattered across multiple chains. And I can tell here that, let me just refresh this. This is just a borrow and lending application that's using, that's looking at multiple Aave v3 pools across 6 different chains. So my Wi-Fi is a bit slow, of course, because I'm doing a live demo on mainnet. So of course it's going to be slow. Okay, there we go. So I have funds on these 6 networks, and I can see that at the moment the highest savings rate is on Scroll, and it's 6.29. And I want to put my USDC to use. So I look here, I see that I only have 6 on Scroll, and I want to supply, let's say, I want to do 20. So usually what I would have to do is I would have to bridge manually, I would have to manage gas, I would have to do a bunch of these different things. But what's happening now in the background is that this entire cross-chain flow is being encoded into a super transaction. My MetaMask is going to pop up, and what I'm seeing here is the root hash of this super transaction. I'm just going to confirm it, I'm going to sign it. What's happening now is this entire cross-chain flow is being executed. Right now, we're going to be executing, I'm guessing, 3 or 4 different transactions across multiple chains. 2 of them have already been executed, and we're waiting for finality on Scroll. What's happening here? We just paid for gas on Optimism in USDC. We are executing a transaction on Base and Arbitrum. These two, I assume, are bridge transactions to Scroll. Once the funds arrive to Scroll, they're going to be supplied to Aave v3 on Scroll. So basically, we just executed 4 different transactions with a single signature. We paid gas on Optimism in USDC to execute a transaction on Base, Arbitrum, and Scroll. Now, you can see where I'm going with this. Like this is, you can get these like super complex flows using modular execution environment. And I'm just going to refresh this, and you'll see here that my savings are 1996. There was probably some slippage, maybe some fee, but my total USDC here was lowered, and here you can see that I'm now on Scroll, getting money. The next example I'm going to do is this EOA support that we have. So this EOA account only has USDC, and what I'm going to do now is I'm going to sign once, and I'm going to execute a couple of different transactions. I'm going to swap USDC for wrapped ETH on Base. I'm going to pay for gas using USDC in a single signature using an EOA. And this is not even using 7702. So you'll see how this works. So I'm just going to get the quote. Whoops, let me try this again. Let me just refresh this. Let's do, I don't know, 5 USDC. I get the quote. What's happening now, once again, the modular execution environment is looking at on-chain conditions on whatever it needs to look. It's calculating gas costs, it's finding the best routes. Yeah, by the way, the Aave demo is using Li-Fi in the background as well. This one, I think, is using also Li-Fi. So what's happening now is modular execution environment looked at on-chain conditions. It found the best route to Li-Fi. I only have an EOA with USDC. I'm going to confirm this. As you can see here, it's 5 USD. And then what's happening now is that modular execution environment is now executing multiple transactions with a single signature and gas abstracted on my EOA. So you can see here, we can take a look at the MEE scan. And there we go. My EOA is paying for gas in USDC. It's bridging from optimism to base, and we're just waiting for finality on base. And then I'm going to get my wrapped ether. So now, all of a sudden, with modular execution environment and super transactions, we get gas abstracted flows on the EOAs without 7702. And with 7702, this is even, we take it a step further. But that's a story for another time. Thank you very much for listening. I hope this was short, understandable, digestible, and thank you.